everything about, we've concluded everything about binary operations. So we started inequalities. So we are going to continue in inequalities. We'll just quickly revise, yes, what I mentioned. I gave the basic symbols of inequalities last time, and I was able to establish that anytime you are trying to solve inequality related questions, you are meant to treat that inequality sign like equal to. You are meant to treat inequality sign like equal to. So at the end of the day, you are going to see that when you treat it like that, it is what will make your work easy. So here I have 2x plus 5 is less than 16. Let me not use 16. Let me use, maybe let me use 13. Yeah, let me use 13. I just want something that will give me a whole number. So 2x plus 5 is less than 13. And so in this case, tactically, what I am going to say, I'm going to pretend to ignore this sign and put equal to instead. So it will now be 2x plus 5 plus 5 is equal to 13. So at the end of the day, what you are going to have is 2x is equal to 13 minus 5. And that gives me 2x is equal to 8. So you divide both sides by 2, and then you have this. So you have your x is less than, no, let me not use the word less yet. I'm going to replace it, is equal to 4. So now I'm coming back. This is not what is originally in the equation. So I will just return what is there. So what I will now have is x is less than 4. So what are the numbers that are less than 4? All I need to do is to put my 4 here and then put the circle. I told you the interpretation last week. X is any number that is less than 4. So you can fix it within the range. It can be -3, it can be -3.5. If it is a whole number, you pick whole number set. -3, -2, 3, 2, 1, 0, -1, -1, it continues. S continues. It's a range of number. It's a range of number. All right. But most times, students get confused about this replacement. So in your mind, you may not actually remove the sign and replace it with equal to. But in your mind, you will assume that what you are dealing with is equal to, so that the sanity of the solution can be preserved by anybody that is looking at it. So I'm going to still take this away. The original equation is 2x plus 5 is less than 13. So what I'm going to do is I'll just go to the new board and rewrite that. So I'm going to have 2x plus 5 is less than 13. So now my mind is seeing this sign as an equal to sign, while I'll preserve this equal to, less than. So it's going to be 2x is less than 13 minus 5. So my 2x will now be less than 8. And I'll divide both sides by 2. You to do this. Let me pause a moment and maybe if there's any question before I move ahead. If there's any question, I can take it now. Okay, if there is none, is there any? Like someone is trying to talk. Okay, So if there is none, I can move ahead. So just like I did the previous one, of course, the interpretation remains. This is my 4 on the number line, and x is any number that is less than 4. So I have this. Okay. All right. So let's move to another one. Um, there are several questions of such. If you have any, because I know some of you are with your past question and answer. If you are skimming through and you see anyone, come across anyone, you can bring it on. Let us just solve it together. This inequality questions comes out even in set theory. There's a way they ask these questions in set theory. And so your understanding, your ability to understand questions in in inequality can save you in some topics or in some questions that will come your way, even in another topic. They can ask questions on inequality in sets. They can ask questions on inequality in simultaneous equation. They can even ask in quadratic equation because there is what we call quadratic inequality. I think somebody's mic is on. You will need to mute your mic so that there will not be. Ola, can you mute your mic? Ola, you can close your mic. Just tap on it, it will close. All right, thank you. So you can listen on. If you have any question to ask, you are free to unmute and then talk to me. But if there is none, so that there won't be a disruption in the instructions. All right, let's move on. Let's talk about this. If you have 2x, maybe I'm using too much of 2x, but it's fine. Minus 6 is less than or equal to 5x, maybe plus. I think we can just deal with any, interesting, let me use still plus 3. Let me use plus 3. 2x minus 6 less than or equal to 5x plus 3. That's what I want to write. Okay. I'll write it here now. 2x I think I used minus the other time. Minus 6 is less than or equal to 5x and then plus 3. This is interesting. All right. So this is a very technical question. And I'm going to be doing some analysis based on this question. If you want to solve this, definitely you should know that you will collect like terms. All right. You collect like terms. So I'm going to have 2x minus, let me use different sign, different color now. Minus 6, and then this is not part, of course, less than or equal to, I love playing with colors, 5x, and then, of course, plus 3. So you can see, I just want to play around identifying like terms. So at this junction, I can bring all the x's together. So 2x, when 5 comes, when 5x is moving to the other side, it will become minus 5x. And of course, that is less than or equal to, and then I have plus 3. 6 is coming to the other side, so it will be plus 6. So 2x minus 5x will be minus 3x. Maybe I should just retain the color so as not to minus 3x, and that is less than or equal to 9. That is less than or equal to 9. All right. So at this point, what we need to do is we divide both sides by -3. And this will do something great for us. Your x, this is where you need to get something because we need to deliberate upon this. Your x now, we now change the sign to greater than or equal to. Now be greater than or equal to -3. The question is, why do we need to change? The first one we didn't change. The second one we didn't change. Why are we changing this? Why are we changing? The sign changes from less than or equal to, and it becomes greater than or equal to. What has happened? Why? Is it not the same way we did the first one that we are doing this one? This is the secret behind it. If you have -5, look at the number line. -5 is here, then 5 is here. In between, we have several other numbers. We know that this -5 is less than 5. But do you know that if I decide to divide both sides of this by -1, this one over -1, this one over -1, this minus will cancel this minus. So I will have 5. You don't expect 5. This is why the sign has to change. You don't expect 5 to be less than -5 because this one will give you -5. You can see now that this is wrong. Let me use a red letter to show that it is wrong. So it has to change. Negative number will always be less than positive number. So because we have divided both sides by minus is the reason why there is a change of sign. Because when you divide a negative number by negative, minus over minus will always give you a plus. And then this is a positive number that you are dividing by negative. Plus over minus will always give you a minus. So a positive number will always be greater than a negative number. And that is why I've used this one here to explain to you. So I need you to note that anytime you are dividing by a negative or you are multiplying by a negative, the sign must always change. You keep that in mind. Anytime you are multiplying by a negative or you are dividing by a negative, the sign must always change. Please note that. Let me give you a moment to ponder on that. If there is a question, I want to attend to it. I'll be waiting. All right. I want to believe nobody has a question. Please practice a lot of questions around this. Very important. Practice a lot of questions. In fact, this question will lead to what I call modeling. And there's modeling in JAM questions. I'm not sure if we will be able to get to that extent tonight. But I did mean that any of you can pop up a question. I would not want to deny you the right to answer that. Lizzie, can I continue from here? I need a response from you. I want to be sure you are getting this.
Yes, sir.
Oh, good. Very good. Thank you. Thank you. Okay, so let's move on to the next one. So if you have something like this, you have to find the graph of 2x minus 5 is less than x plus 3, and that is also less than, I want to write about 3 equations. I've written 2. So pardon me that because it's my phone screen I'm using. So, and it's a continuation. Let me see if I can erase and squeeze it in back. 2x minus 5 less than x plus 3. So you have 2x minus 5 less than x plus 3. And that in turn is also less than or equal to less than or equal to 2x plus 7, right? If you have something like this is what I call simultaneous linear equation or simultaneous inequality. Simultaneous linear inequality. It's an equation in two reference of frames. You don't solve it like normal simultaneous equation. Simultaneous inequality cannot be solved using elimination method or substitution method or graphical method. The way you are going to solve simultaneous equation. So this one has a peculiar way of solving of its own. And you will notice something here that this simultaneous inequality is in one variable. There are simultaneous inequality in two variables. Yeah, you can solve simultaneous inequality in two variables. But then before you'll be able to do that, you need to use what I call segmentation. Now, this is what I meant by that. This, you can group it in twos. So let me use another color. You can group it in twos. So I can decide to first group this together, and then I will also group this together. So let me call this group 1, no, this group 2. I'm changing this color, and I'll call this one group 1. Come on, write it up, group 1. So I want to solve group 1 first. So group 1, what does that mean? What does solving group 1 mean? What solving group 1 means is that I'm going to solve this equation I underlined in blue first. So it's going to be 2x minus 5 is less than x plus 3. And of course, when you collect like terms, that will be 2x minus x is less than 3 plus 5, collection of like terms. So x must be less than 8. You have just solved the first part of the equation, or what I call group 1. Then we want to solve group 2 now. Group 2. So to solve group 2, I will pick the one under which I have put, over which I have put a line. That means x plus 3 must be less or equal to 2x plus 7. X plus 3 must be less or equal to 2x plus 7. So how do I solve this? I will say x minus 2x then must be less or equal to 7 minus 3. So in this case, minus x must be less or equal to 4. Then, like I told you, you have to multiply both sides by minus or divide both sides by minus. So if you divide both sides by minus, then you should know that x will be what? Greater than or equal to minus 4. You can see that now. So I want to now, at the end of the day, combine and this answer. I want to combine that answer that I've wrapped in green. I need to combine them as one. I need to combine them as one. In order to combine them as one, I just want to take this away here. So, okay. Here, good. So if I combine them as one, or maybe I should just do this to this. It's the same thing. Multiplying by minus is the same thing as dividing by minus. It's either you multiply by minus or you divide by minus, you get the same result. Yeah, you get the same result. So this is working for me. Okay, so I want to combine these two now. So to combine these two, I have x is less than 8, and then x is greater than or equal to minus 4. So let me combine it on the next one. So I have x is less than 8, and I also have x is greater than, is actually greater than or equal to minus 4. So how do I combine this? Of course, I will now write it in this format. Minus 4 is of course less than x or equal to x, but at the same time, this very x is less than 8. I've just written everything as one single equation. This finally is my answer, and I can write it in graphical form. Minus 4 is here, 8 is here. So here I will shade because I have less than or equal to. Here I will not shade, so I will write this. So x is any value in between the two of them. When you have something like this is what we call simultaneous linear inequality. So if you have any question again, let me know. Maybe
Sir,
for the sake. Yeah, go ahead.
please, I don't have question, but I don't know if you can give us some questions to solve so that we'll submit it tomorrow in the group. So we'll
Okay.
try if we try our best or not.
Okay. Okay. Give me a moment. Let me just check my library on my phone. If I can have, of course, I should be able to have. While I'm trying to search my library, does anybody have any reason why I should go back to previous slide? Okay. Let me quickly search my library. I should have one. Let me pick from here. Have some repository okay. Yeah, repository. Okay. Let me do it this way. Okay. So let me pick questions from this ebook. So I might have to stop sharing my board. So I want to be sure that all of you have copied what you are. Okay. Okay. All right. So we are going to be fast with it because you know our Zoom timing is somehow. So I'm bringing down my screen to be able to share the book that we can pick questions from. And I need you to be fast if you need to. So these are topics under inequalities, and we discuss some of them. Okay, so join here. Okay, so here you have question here. All right. These are jam type of a question that you can check. Look at questions here. So maybe you just these ones are simple ones, so you can screenshot if you want. This is 1 to 6 of the question. Lay your hands on any one of interest, and I can also show you on the other part. These are questions. You can also screen grab this. Just want to bring it close, Okay. All right. You can screen grab. These are questions. Find the values of y satisfying the inequalities. You can deal with all of this. Okay. Find all the real value. I love this question 11. Find all the real numbers and for which this is greater than this. And then the options are there. So it's not that when you solve, you say, yeah, my answer is not there. It's actually, though, once in a while possible, but then this is what you can try your hands on. Let me still go this far. I think you'll be happy to want to try your hands on any of this. Okay. It's so pure. All right, just screen grab it. Yeah. So you have enough questions, please. Practice, practice. I need you to practice. It helps. You can see when I was explaining to you the other time, I was just bringing questions without having to refer to books. But, when you have all of this can help too. This is another set of questions. So I think you are okay with this in a way. Let me bring this up so that the options can be clearer. And yeah, I think this is fine. Okay. I want to believe you are you are doing the screenshot of all this because you may not have the luxury of time to write them down because of time. How many of these can you write down in a few minutes? Once you have them in your screenshots, you can practice with them. All right. Let's go to a more complex one. These ones are the ones that we may not be able to reach out to today. This is what I call modeling. That's question 33, question 32, question 33, question 31. They are called modeling. So if you have a textbook that can help you, go and read up on all this. Maybe next week when we now meet, when we are solving questions, I will guide you into how you should be able to solve all of this very, very effectively. Okay?
Thank you, sir.
All right. And then these two of interest too. You can see they are all inequality questions. They are all inequality questions. Inequality is very wide. Very wide. So if you have enough questions to practice with on your own, it will make us to speed up. And we have the answers here, though, but I'm not going to let you into all that. So these are the solutions, but don't worry about it. You can explain. Possibly maybe next week, after the class, after we might have solved a lot of questions, we can move into sequence and seriousness, and then discuss some further questions around sequence and series. So that is all that for now. You have the questions. Okay, so it's fine. So is there any other person that has question for me? Or maybe you are quickly going through each of those questions. You think there is one you want me to solve for you, fine. You can quickly deal with it if you want. Okay. I'm not getting any response, means you are doing well. Okay. So please note that that is inequalities for you. Let me still see if I can do something else before our time got used up. And I want you to actually try and read too, ahead of the class in a way. Let me see if I can pick it up from here. I think I have some. I want you to be, okay, not sure I have them here yet. Okay, let me just look for it elsewhere. Okay.
Hello, sir.
Yes, sir.
So are you done with this one?
Almost. I want to give them a material that will help them, and let me see it from here if I can pick it up. Okay. Let me see if this will work. I'm not sure if I'll be able to upload it to, but I'll try. I know there is a way I should be able to do that. I don't know if it will work here. If it doesn't work, okay, I'm not sure it will work. It won't work. I won't be able to upload it to Zoom. Okay. So I think that's all we have for today. Since they have enough questions to practice with, they should be able to relate well with the simple explanations. So at this point, I want to believe I've done a good job. There's nothing to ask. That means everybody understands the concept well. So the aspect we are just going to concentrate on is the graphical aspect, which I call the modeling. You have the questions already. So when I'm explaining it next week, it won't be, next class, it won't be difficult for you to understand. So at this point, I think I'm done. I think I'm done here now.
Thank you very much, sir. Good night.
You are welcome.
We'll be starting physics immediately. So come to physics, eh?
Okay, sir. Thank you.
All right.